3. Hi, so this was a question that we were doing at the end of last lesson and we didn't get as far as part 4, so I thought we would have a go at part 4. So obviously I know it might not be very easy to see on the screen, so I have, I'm just checking I'm recording, yes I am, I have sent you a copy. Right, part 4. The minimum mark for grade A, the top grade on paper 1 was 10 marks lower than the minimum grade for the minimum mark for an A on paper 2. Given that 25 candidates gained an A in paper 1. So let's go to paper 1. So we know that there's 200 candidates, so we would come down 25 to 175, wouldn't we? So here we are. So it's just paper 1. Oh, it's so tricky to spot. I put my glasses on to look in there. So I can see that I'm 1 in. So if I come down here, I'm going to be A or very poor. Obviously, you use a nice ruler. I'm going to say 68. So I think if 25, so I'm talking about these 25 candidates getting an A on paper 1. So on paper 1, the mark on paper 1 for an A was 68. And that is 10 marks lower than on paper 2. So on paper 2, an A, that would have to be 78. So let's now go to 78 and read off the cumulative frequency. So here's 78. I want to, oh, it's so fiddly. Is it there? I want to say 78. And then you see, I think it's halfway between the squares. Could it be? So we know that every little square is 5. So I'm thinking 162, 163. Okay. So we know if that's 162, 163, possibly even 160, it's quite hard to read off. I'm looking at the difference. So 200 take away 162, 163. I'm going to say roughly 37. So let's have a look at how they've marked that. Oh, 37, and can you see that they've been really nice? They've allowed you to have, this is the thing with stats, why people love it. I love it, but some people are like, oh, why so generous? But 34, 40, anything between there. Okay, right. So what I would like you to do, we're going to leave that one. I would like you to have a go at this question. So this is question, and it will be question 2. So I've sent it to you. It's question 2. It's a past exam question, and I think it would be good for you to have a little go at. So if you'd like to pause the video and maybe download the question, because I think it's probably going to be too tricky for you to do off the screen, but I know some of you are very eagle-eyed, so you might be able to. So if you have a little go at that. Okay, so just pause the video and enjoy this question. Okay, now to mark it. So you've done that question. So here are the solutions. So here's the mark scheme. So you can see they're saying 590. They're saying part 2, it's the graph becomes horizontal for anything greater than 55 marks, levels off, something like that. Part 3, they're accepting 39 to 41. And part 4, attempt to read cumulative frequency at 26 to 27. So they're saying max C 29 to 31 and a half. Lower quartile 25.5 to 26.5, or upper quartile 34 to 35.5. Interquartile range is between 8 and 10. And German is more spread. You could say less consistent, less uniform, less similar, more varied. You can. Oh no. Sorry, it just gave me a low power mode. Okay, what I should have done is while you'd paused the video, I should have run and got my lead. Right, box and whisker plot. I think I'm still recording. I'll be really upset if I'm not. So, box and whisker plot. So you've met this at GCSE and A-level. I think we might at GCSE just call it a box plot, but it's full on old-fashioned at A-level. It brings the whiskers back, and of course the whiskers are the maximum and minimum values. Now the thing about the box and whisker plot is that it's summarized data. So you can't, you can't even see how the data is grouped, but instantly you can look at it and you can say what the median is, what the interquartile range is, what the range is, what the maximum is. You've got it summarized, so it's really useful for comparing two sets of data. So if you can just have a little look, it's very useful for dealing with from cumulative frequency. So you can see that once you've got your cumulative frequency curve drawn, look at this, I love this graphic of my maths, I miss my maths. In fact, there is some reasonable A-level stuff on here. It's just, it's not that great for stats, but some of the pure is pretty good. We might have to start using it again. So you can see it's got the markers there for your lower quartile, your median, your upper quartile, and your maximum. And it makes your box. So obviously your lower quartile line, your upper quartile line, and your median. And there we have our box and whisker plot. No longer just called a box plot. It does need some form of axes. In this case, it's obviously sharing its axes with the horizontal axes of the cumulative frequency graph. I don't know. And then there's all sorts of things that it might ask you to interpret. So you can easily see how to find your interquartile range. Right. We love them for comparing data. So box and whisker plots, comparing two sets of data. You can see it's got its axes here above it. So the first question you've got, so two surveys were taken of the ages coming into the patient of the ages of patients in two hospitals, Hospital A, Hospital B. Find the medians for each hospital. So, oh, cool, blimey. It's not the best, is it? So imagine that that's a better axis. So you're looking maybe for A. It's the, obviously we can't be super precise here. 52. And for B, are we looking more 50? Okay, it's pretty poor actually. This. Which hospital has the highest average age? And that would be A. Find the interquartile range. Again, we're going from a very, very crude axis here, but it's just the idea. So for the interquartile range, you've got A. I'm saying you're going from 60 to 30. So your interquartile range is 30. For B, well, it's really easy for you to see that's completely different, much smaller. B interquartile range is 60 minus 40, which is 20. So the hospital which has the greatest spread of ages over the middle 50%, which is what the interquartile range is A. 25% of hospital A are under what age? So here we have the lower quartile and they are under the age of 30. In which hospital are the age ranges more spread out? Well, here would we say that that's going from 5 to 70? So A has a range of 70 minus 5, so 65, and B, we've got a wowzer. So we go looking here, 90, I'm going to say 92 and 15. I'm almost making those up, but 92 take away 15. So you can see that we've got quite a big old range there. So is that going to be 87? Hospital B, a bigger range. Okay,